As we have discussed, the volume of a tetrahedron and volume of a parallelepiped. If A bar, B bar, C bar represents the coterminous edges of a parallelepiped, then the box of A bar, B bar, C bar represents a volume. What about the volume of a tetrahedron? V is equal to plus or minus 1 by 6 into box of A bar, B bar, C bar. Plus indicates they are in right-handed system. Minus indicates they are in what? Left-handed system. In the same fashion, for a tetrahedron ABCD, the volume of a tetrahedron can be written as 1 by 6 into box of AB bar, AC bar, AD bar. Now, I want to prove when 4 points are said to be coplanar. Note the points capital A, B, C, D are coplanar if and only if box of AB bar, AC bar, AD bar is equal to 0. When the 4 points are given, say for example, OA bar is equal to A bar, OB bar is equal to B bar, OC bar is equal to C bar, OD bar is equal to D bar. If you want to prove them as coplanar, nevertheless, you have to show that box of those 3 vectors is equal to 0. Det of those 3 vectors is equal to what? 0. So therefore, now how to prove this one is, the proof of this one is very simple. If A, B, C, D are the vertices of a tetrahedron, then its volume is equal to 1 by 6 into box of AB bar, AC bar, AD bar. If 4 points are coplanar, then the volume of a tetrahedron is equal to what? 0. Which implies box of AB bar, AC bar, AD bar is equal to 0. Remember, hereafter if you want to prove that any 4 points as coplanar, box of AB bar, AC bar, AD bar is equal to 0. Now, let us give one example for this. If I take the points 1, 2, 3, minus 1, minus 1, 2, 4, 3, 0, 0, 1, 2, right? R dash, the options are coplanar, non-coplanar, and third one is neither coplanar, non-coplanar, fourth one is none. Now what I do is, when they are given the points in terms of the coordinates, certainly they must be expressed in terms of Ijk. You take OA bar is equal to 1, 2, 3, OB bar is equal to minus 1, minus 2, and OC bar is equal to 4, 3, 0, OD bar is equal to 0, 1, 2. First you find out AB bar. What is AB bar? OB minus OA. This minus this, minus 2. This minus this, minus 3. This minus this, minus 1. Then AC bar, OC minus OA. This minus this, 4 minus 1. 3. 3 minus 2, 1. 0 minus 3. This is. Next, I go for AD bar. What is AD bar? OD minus OA. OD minus OA means 0 minus 1 minus 1. 1 minus 2 minus 1. 2 minus 3 minus 1. Just you find out box of AB bar, AC bar, AD bar. Box of AB bar, AC bar, AD bar. Now I go for the what? They are in terms of IJK. I can write this one as minus 2, minus 3, minus 1. Yes, 3, 1, minus 3. Yes, minus 1, minus 1, minus 1. Expand this. I can write minus 2 into minus 1, minus 3. Minus of minus plus 3. Now into 3 minus 3. Minus 3. Okay. Minus of minus plus. Once again minus. Minus 1 into, yes, come on, minus 3. Next plus 1. I can write this one as minus 3 plus 1. Minus 3 plus 1. So now you expand. This becomes 8. This becomes what? 6. Minus 18. This becomes what? Plus 2. So therefore, this is not equal to 0. Therefore, the points capital A, B, C, D are what? Non-coplanar. If it is equal to 0, they are what? Coplanar. Right. So hereafter, whenever the points A, B, C, D are coplanar, if and only if box of AB bar, AC bar, AD bar is equal to 0. With this one, we shall also find out one important condition for the points to be coplanar in a general form. Yes, under the same condition, the points A, B, C, D are coplanar if and only if box of AB bar, AC bar, AD bar is equal to 0. If I take OA bar is equal to A bar, OB bar is equal to B bar, OC bar is equal to C bar, OD bar is equal to D bar, right? Now I go for this one is, what's the condition? The condition is B bar minus A bar, C bar minus A bar, D bar minus A bar. I am substituting AB bar, AC bar, AB, OB minus OA, AC, OC minus OA, AD, OD minus OA. This is one condition. We can also get another condition for it when points are given. Now by using scalar triple product, box product is nothing but C bar minus A bar cross of D bar minus A bar is equal to 0, right? Followed. Now I can take this one as B bar minus A bar dot of, take the what? C cross D minus C cross A, take the cross product, minus A cross D minus of minus plus A bar cross A bar. Now this says nothing but 0, right? Now I can write B bar minus A bar dot of C bar cross D bar minus C cross A minus of minus plus D cross A. I take it, change the cross product, minus A cross D is equal to plus D cross A. Now dot product of B with this, a dot product of A with this. I can write B bar dot of total bracket C bar cross D bar, C bar cross A bar, B bar dot of D bar cross A bar is equal to minus of, if you transfer that, it will become A dot of C cross D minus C cross A. It's a D cross A, right? So therefore, now this becomes B dot of C cross D minus B dot of C cross A plus B dot of D cross A. Now this is nothing but A dot of C cross D minus A dot of C cross A, that is plus A dot of D cross A In a scalar triple product, if two vectors are identical, the value of the scalar triple product or a box product is equal to 0. Therefore, this is 0. This is 0, right? So now coming this one is, I can write box of BCD minus box of BCA, right? Next, box of BDA. Now I can write this one as box of ACD, right? Box of ACD. So now coming this one is, here I can write in a box product, dot and cross are interchangeable in a cyclic order. I mean, vectors can be interchangeable in a cyclic order without the order sign changes. So therefore, now you change this as box of A bar, B bar, C bar. Therefore, minus becomes plus. Next, this becomes plus B bar, D bar, A bar is equal to box of ACD. Okay, this is the condition for any 4 points to be coplanar. To be coplanar. So therefore, whenever the points capital A, B, C, D are coplanar, box of AB bar, AC bar, AD bar is equal to 0, or else box of B bar minus A bar, C bar minus A bar, D bar minus A bar is equal to 0, or else this sum of the 4 boxes is equal to what? Some conditions, right? We shall find out vector equation of a plane by using the concept of what? Scalar triple product. We have found out already the vector equation of a plane in vector addition of 2 vectors or 3 vectors or 4 vectors. The vector equation of a plane passing through one point and parallel to 2 vectors is R bar is equal to A bar plus SB bar plus TC bar. That is one way. The another way is the same plane equation can also be expressed as in terms of box. This here will be having much more applications. What is that? Now the vector equation of a plane passing through the point A bar and parallel to B bar and C bar is. Look here. Now I can express in many ways of this. Now I take this one as plane equation like this. Now it is passing through one point. You select what origin. When one point is given, this is A of A bar, this is P of R bar, this is OA bar, this is AP bar. When one point is given, you have to select a second point to name it as a plane equation. Meanwhile, this plane is what? This is B bar, this is what? C bar. Now plane is parallel to what? B bar and C bar, or else the vectors B bar and C bar is parallel to plane. Now what I do is I start like this. Now the proof of this one is, now let OA bar is equal to A bar, OP bar is equal to R bar be the position vectors of capital A comma P. Okay, let B bar comma C bar be the vectors parallel to plane. Now you can very well observe AP bar, B bar, C bar are lying in a same plane, which implies AP bar, B bar, C bar are coplanar. When they are coplanar, Now I can write in one way. Case 1, first way. Case 1 means in first way. So now I can write one vector can be expressed as scalar linear combination of one vectors where s comma t belongs to R. This is one way. Now case 2. What is case 2? Case 2 is what? The another way is when they are coplanar, box of AP bar, B bar, C bar is equal to 0. Case 3. Yes, you concentrate on this, you'll get many applications, very quite interesting. So therefore, case 3, in 3 ways we can write this one as case 3. What is that command? Det of what? AP bar. So I'll write this one is later, that case 3. Now this is nothing but AP bar OP minus OA is equal to SB bar plus TC bar. This is R bar minus A bar plus SB bar plus TC bar. This is nothing but R bar is equal to A bar plus SB bar plus TC bar. Already we proved in addition of vectors. If you have all this, it will be having good comparisons. Okay. Now box of, what is this one? Box of R bar minus A bar, B bar, C bar is equal to 0. Why? OP minus OA. Box of, now look here, box is nothing but a determinant. In a determinant, if the elements of any row or a column is sum of two terms, then that determinant can be expressed as sum of two determinants. Followed? So therefore, I can write box of R bar, B bar, C bar, A bar, B bar, C bar is equal to 0. Therefore, I got it. Box of R bar, B bar, C bar is equal to A bar, B bar, C bar. That's right. This is one way. This is one way, right? This is one way of writing. Otherwise, I can also write in terms of what? Scalar triple product. That is R bar dot of B cross C is equal to box of A, B, C. This is also another way of writing. This is also, look here, the vector equation of a plane passing through the points A bar and parallel to two vectors is, one is this. Already you are well familiar. The another way is box of them is equal to 0. That means box of AP bar, B bar, C bar is equal to 0. Therefore, box of R bar, B bar, C bar is equal to box of A, B, C. Or else, by using scalar triple product, R bar dot B bar cross C bar is equal to box of A, B, C. Now, what is the third method? Third method is if OP bar is equal to R bar is equal to Xi plus Yj plus Zk, and Y bar is equal to A bar, A1i plus A2j plus A3k. B bar and C bar are two vectors which are parallel to the plane. In turn, B bar is equal to B1i plus B2j plus B3k. C bar is equal to C1i plus C2j plus C3k. So therefore, AP bar OP minus OA means R bar minus A bar. So therefore, X minus A1, Y minus A2, Z minus A3. Followed? So therefore, now this is B bar, B1, B2, B3, C1, C2, C3, right? Directly it gives Cartesian equation of a plane. In terms of, this may be in terms, it may leads to what? AX plus BY plus CZ plus D is equal to 0. This represents a plane equation in terms of what? X, Y, Z. You see, it is quite interesting. Only one theorem we are able to express in three ways. One is a linear combination. R bar is equal to A bar plus SB bar plus TC bar. Another one is what? Come on, box of R bar, B bar, C bar, box of ABC. Or else R dot of B bar cross C bar is equal to what? Box of ABC. Another one is what? Cartesian equation of a plane. Yes, now a real discussion starts. What he says, especially comprehensions, assertion and reasoning, and statements. In that questions, instead of giving the numericals, if he asks the perpendicular distance from the origin to the plane passing through the point A bar and parallel to the vectors B bar and C bar. If it is points, numericals, it's very easy to find out. Okay, just you write down the what plane equation. For this plane, you go to the planes. I write down what is the perpendicular distance from the what point x1, y1, z1 to the plane ax plus by plus cz plus d is nothing but modulus of ax1 plus by1 plus cz1 plus d by square root of a square plus b square plus c square. You can use. Instead of that, he is asking in terms of a bar, b bar, c bar. Look here. Now if I go to this one is, I take this as a star. In this one, I want to find out the perpendicular distance. This is in the form of r bar dot n cap is equal to p. Convert in this. Why? Already in the dot product we come across one important theorem or a concept oriented discussion. R bar dot n cap is equal to p represents the equation of a plane where n cap is the perpendicular to what plane and p be the perpendicular distance from the horizon to the plane. Now I want to find out the perpendicular distance from the horizon to the plane. That plane is passing to the point A bar and parallel to the vectors B bar and C bar. Now first of all I want to convert this. Now r bar dot of n cap b bar cross c bar by modulus of b bar cross c bar is equal to s box of a bar b bar c bar by modulus of b bar cross c bar. Yes, got it. Now look here. Now this is nothing but p. So therefore what is p? Now I can write this is nothing but I can write p is equal to p means perpendicular distance from horizon to the plane. What's up now? Plane is modulus of box of a bar b bar c bar by modulus of b bar cross c bar. So therefore this is the formula to find out the perpendicular distance from the horizon to the plane. That plane is passing through what? A bar and parallel to what vector? B bar and C bar. Sir, if it is this one is, if you go like this, you can also find out perpendicular distance from the horizon to the what plane. You can, after knowing this one is the perpendicular distance from horizon, the perpendicular distance from horizon to plane ax plus by plus cz plus d is equal to 0. A is nothing but now 0 plus 0 plus 0 plus d by square root of what? A square plus b square plus c square. Nevertheless, mod d by square root of what? A square plus b square plus c square. Followed? You see, in one theorem, we come across about 6 discussions. So therefore, whenever you take any one application, always think about its ends. So therefore, the vector equation of a plane passing through the point A bar and parallel to what? B bar and C bar. Yes, let OA bar is equal to A bar, OP bar is equal to R bar with the what position vectors of A, B. B bar, C bar with the vectors parallel to the plane. Yes, AP bar, B bar, C bar. From the figure, they are lying in the same plane. When B bar and C bar are parallel to this is the what? A plane containing AP bar. When B bar is parallel to it, C bar is parallel to it. What's the definition of coplanarity? The vectors which are lying in the same plane or parallel planes are nothing but what? Coplanar. So therefore, now I can write, now this is coplanar. When they are coplanar, you can write in 3 ways. One is one vector can be expressed as linear combination of remaining vectors. AP bar is equal to SB bar plus TC bar, OP minus OA, R bar minus A bar. Therefore, R bar is equal to A bar plus SB bar plus TC bar. Next, box of them is equal to 0. Write down as R bar minus A bar, B bar, C bar. Now this can be expressed as difference of 2 box products. Box of R bar, B bar, C bar. Yes, A bar, B bar, C bar. Transfer this side. This is one way. The another way is now box is nothing but a scalar triple product. This also you can write. So therefore R bar dot of B cross C, that is box of ABC. This is, after knowing this one is, you can also convert in what form? R bar dot n cap is equal to P. Why? I want to find out a perpendicular distance from the horizon to the plane. That plane is passing to the point A bar and parallel to the vectors B bar and C bar. So therefore I can write R dot of n cap. You have to convert it as a unit vector. So therefore its direction by its magnitude, multiply on both sides with what? B cross C. B cross C is nothing but a scalar. Modulus of B cross C is nothing but a scalar. Therefore B cross C by modulus of B cross C. This by modulus of B cross C. Therefore this is nothing but a P. Therefore P is nothing but perpendicular distance from the horizon to the plane is given by modulus of box of ABC by S B bar cross C bar. The another way is when three vectors are coplanar, determinant is equal to what? 0. Y box is equal to 0. What is AP bar? OP minus OA. R bar minus A bar. R bar is equal to XI plus YJ plus ZK. A bar is equal to what? A1I, A2J, A3K. B bar is equal to B1I, B2J, B3K. C bar is equal to C1I, C2J, C3K. So therefore X minus A1, Y minus A2, Z minus A3. That is two vectors are parallel. B1, B2, B3, C1, C2, C3 is equal to 0. After expansion, you get Ax plus By plus Cz plus D is equal to 0. That gives directly Cartesian equation of a plane passing through the point A bar and parallel to vectors B bar and C bar. So if you know this, we can, instead of going by this method, if you want to find out the perpendicular distance from the horizon to the plane, directly you can go for mod D by what? Square root of A square plus B square plus C square. But if it is in terms of A bar, B bar, C bar, this is very conceptual. If it is numericals, you can go by this, don't go by this. Why? It is bit laborious. Box of ABC is a one determinant, B cross is another determinant. You have to find out two determinants, then you have to find out. It's a waste of time. But for conceptual questions, statements, assertions and passages, you can go for this. This is all about the vector equation of a plane passing through the point A bar and parallel to the vectors B bar and C bar. Students, let us recall the theorem, this concept. Still, for clarity, we can go for one or two examples. Example: the equation of a plane, passing through the point capital A of 1, 2, 3 and parallel to the vectors B bar is equal to 3, 4, 0. C bar is equal to 0, minus 1, minus 1. And also perpendicular distance from horizon to the plane is dash. Okay, I start. OA bar is equal to 1, 2, 3. OP bar is equal to R bar is equal to X, Y, Z. Be the position vectors of capital A, P respectively. Then, and B bar, C bar be the vectors parallel to plane. I go to this one. This is A of A bar, P of R bar. This is B bar. This is C bar. Now I can write, which implies AP bar, B bar, C bar are coplanar. I can write box of AP bar, B bar, C bar is equal to 0. I can write this one as AP bar x OP minus OA, R bar minus A bar, x minus 1, y minus 2, z minus 3 is equal to 0. Now B bar and C bar. What is B bar? 3, 4, 0. 0, minus 1, minus 1. Now you expand this, x minus 1 into 4 minus 4 minus 0, y minus 2 into minus 3 minus 0 plus z minus 3 into minus 3 minus 0 is equal to 0. Therefore, minus 4x plus 4 plus 3y plus minus 6 minus of minus plus minus 3. Next, minus 3z plus 9 is equal to 0. Therefore, minus 4x plus 3y minus 3z, 4 minus 6 minus 2, this is plus 7 is equal to 0. This is nothing but equation of a plane passing through the point A bar and parallel to the vector B bar and C bar. If they ask in terms of what? Box of R bar, B bar, C bar, you can also write it is equal to box of ABC. That is one way. That is one way of writing that. So therefore, now another one is, if you don't want, you can also write box of R bar, B bar, C bar is equal to A bar, B bar, C bar. You can also write. It all depends upon the options it is required. So therefore, next, I want to find out P, perpendicular distance from P of, okay, some Q of x1, y1, z1, okay, is nothing but origin to the plane ax plus by plus cz plus d, okay, plus d is equal to 0 is same as, this is minus 4x plus 3y minus 3z plus 7 is equal to 0. A is equal to modulus of ax1 plus by1 plus cz1 plus d by square root of a square plus b square plus c square, right? Now this is nothing but, come on, substitute 0 comma 0, y origin 0 0 0 plus 7 by square root of 16 plus 9 plus 9. So therefore 7 by that is now 16 plus 9 25 plus 9 34. 7 by 34 is the perpendicular distance from the origin to the plane passing through the point A bar and parallel to the vectors B bar and C bar, right? Let us discuss about another application of scalar triple product in finding the vector equation of a plane passing through 2 points parallel to one vector C bar. What is that? I can go to this one is the vector equation of a plane passing through the points A bar comma B bar and parallel to the vector C bar. Here A bar and B bar are the position vectors. A bar and B bar are the position vectors. And C bar is the what? Vector. I go to this one is the figure. Now A of A bar, B of B bar, P of R bar. Now if I take a origin OP bar, OA bar, OB bar, this is the vector C bar parallel to it. Now you can very well observe AP bar is a one vector, AB bar is another vector, C bar is a third vector. All the three vectors are lying in a same plane. What they are? Coplanar. What they are? Coplanar. So therefore, when they are coplanar, you can express in many ways. Let us see what it is. The proof of this one is very simple. Let OA bar is equal to A bar, OB bar is equal to B bar, OP bar is equal to R bar, be the position vectors of capital A, comma B and P respectively. C bar is the vector, C bar is the vector parallel to the plane. Now, from figure you can apply, you can very well observe AP bar, AB bar, comma C bar are lying in a same plane, which implies AP bar, AB bar, comma C bar are coplanar. Then you can write in another way. This is third way, right? Let us see what it is. Now I can write AP bar, one vector can be expressed as linear combination of another vector. AP bar is equal to S into AB bar plus T into AC bar. The another one is box of AP bar, AB bar, C bar is equal to 0. So now this is one first way, this is second way, this is third way, right? What is that? Determinant is equal to 0. Now I can write this one as AP bar OP minus OA, R bar minus A bar, S into B bar minus A bar plus T into C bar. So therefore R bar is equal to 1 minus S into A bar plus SB bar plus TC bar. Followed. Now coming this one is here, this is already we come across in addition of vectors. Now another way is box of R bar minus A bar, B bar minus A bar, C bar is equal to 0, right? This is one way. This is also one way of writing the plane equation, passing the 2 points parallel to one vector. Arise, I can also write R bar minus A bar dot of B bar minus A bar cross C bar is equal to 0. Now R bar minus A bar dot of B cross C minus A cross C. Now another one is R bar dot of B cross C plus C cross A. Interchange the cross product as C cross A. Minus comes minus of minus plus. Now A dot of B cross C plus C cross A. Now I can write this is, I can also write this is also what? R bar dot of B bar cross C bar cross A bar. Now you take A dot of B cross C, A dot of C cross A. If two vectors are identical, the value of the box or a triple product is equal to 0. I can write A dot of B cross C. This is nothing but the vector equation of a plane passing through the points, 2 points A bar, B bar, and parallel to vector C bar. Maybe this, maybe this. I can also write in another way, R bar dot of B cross C plus C cross A is equal to box of A bar, B bar, C bar. This is one way. Okay. Now here another discussion comes as we did in the previous theorem concept. What is this? These are very important. I want to find out, for concept oriented, I want to find out the perpendicular distance from the origin to the plane passing through the 2 points A bar and B bar and parallel to the vector C bar. So therefore, I want to write in the form of R bar dot n cap is equal to P. As we know already, as we have dealt in earlier, R bar dot n cap is equal to P represents the equation of a plane where P is the perpendicular distance from the origin to the plane and n cap is the unit vector perpendicular to it. So therefore, I want to convert it. This is in the form of, so therefore, I go to here, right? I transfer to this one is, so therefore, now R bar dot of, yes, B bar cross C bar cross A bar whole divided by, it's a real number, B cross C plus C cross A, right, is equal to box of A, B, C whole divided by modulus of B cross C, C cross A. So therefore, what is P? P is the perpendicular distance. You can take this as perpendicular distance cannot be negative. So therefore, B cross C plus C cross A. This represents a perpendicular distance from the origin to the plane. That plane is passing through how many points? 2 points, A bar and B bar, and parallel to what vector? C bar is given by box of A bar, B bar, C bar by modulus of B cross C plus C cross A. In the previous one, box of ABC by what? Modulus of B cross C. This is very, very important. So therefore, next, when you know the perpendicular distance in terms of vector notations, right? Now I want to go for the Cartesian notations. AP bar, AB or C bar are coplanar. Then box of AP, AB, C bar is equal to 0. What is AP? R bar minus A bar, B bar minus A bar, C bar. Let us consider R bar is equal to Xi plus Yj plus Zk. A bar is equal to A1i plus A2j plus A3k. B bar is equal to B1i plus B2j plus B3k. C bar is equal to C1i plus C2j plus C3k. So therefore, AP bar is nothing but, look here, R bar minus A bar, X minus A1, Y minus A2, Z minus A3, X minus A1 into I plus Y minus A2 into Z plus Z minus A3 into K. Next, now AB bar, OB minus OA, B1 minus A1 into I, B2 minus A2 into Z, B3 minus A3 into K. C bar, next this becomes C1i, C2j, C3j. So if you expand, this is will be in the form of ax plus by plus cz plus d is equal to 0, right? If instead of this perpendicular distance, for numericals, for examples, this is laborious. Don't go by this method. Why? This is one determinant, another determinant, third determinant. Who will expand? Instead of that, go to this one is find out the Cartesian equation of a plane passing through 2 points and parallel to one vector in this form. Write down the perpendicular distance as we have discussed. P is equal to modulus of d by square root of a square plus b square plus c square. Followed? Yes. Now what we proved, the vector equation of a plane passing through the points a bar comma b bar and parallel to the vector c bar is, I can write one way, that is one vector can be expressed as linear combination of remaining vectors. AP bar is equal to s into AB bar plus t into c bar, or that is OP minus OA, OB minus OA, R bar minus A bar. We got it. R bar is equal to 1 minus s into A bar plus SB bar plus TC bar. The another one is box of AP bar, AB bar, C bar is equal to 0. So therefore, box of R bar minus A bar, B bar minus A bar, C bar is equal to 0. This is one way. Another way, the third one is by using scalar triple product, that is R bar minus A bar dot of this, take the cross product, transfer to that side. Here, two vectors are identical, box of ABC. So therefore, R dot of B cross C plus C cross A is equal to box of ABC. This represents a vector equation of a plane passing through 2 points and parallel to what vector? C bar. Meanwhile, this I want to write, this is in the form of R bar dot n cap is equal to P. Why you want to express in the form of R bar dot n cap is equal to P? My context is I want to find out the perpendicular distance from the horizon to the plane passing through the 2 points A bar and P bar and parallel to the vector C bar. So therefore, now multiply both sides to convert as a unit vector, divide on both sides with what? So multiply means 1 by modulus of B cross C plus C cross A. Divide means modulus of B cross C plus C cross A on both sides. So I have expressed in the form of R bar dot n cap is equal to what? P. P is nothing but perpendicular distance from the horizon to the plane passing through 2 points A bar comma B bar and parallel to vector C bar is modulus of box of ABC by B cross C plus C cross A. This is by using in terms of vectors. If you don't want in terms of vectors, so then you can go by what? This is applicable only for what? Problems, numericals. So therefore, sometimes they'll go for what? Concept oriented, that for statements they'll give like this only. So therefore, now another one is, the third method is, now box of AP bar, AB bar, C bar is equal to 0 means determinant is equal to what? 0. Determinant of what vectors? AP bar, OP minus OA, R bar minus A bar, AB bar, OB minus OA, B bar minus A bar, C bar. When R bar is equal to X comma Y comma Z, A bar is equal to A1, A2, A3, B bar is equal to B1, B2, B3, C bar is equal to C1, C2, C3. Write down the box of AP bar, X minus A1 into I, Y minus A2 into Z, Z minus A3 into K. Next, AB bar. Next, C bar. Expand it. This is the Cartesian equation of a plane. Instead of this perpendicular distance, you can also find out P is equal to mod D by square root of A square plus B square plus C square gives the perpendicular distance from the horizon to the plane passing the 2 points and parallel to one vector. Yes, so let us recall this concept by giving one example as a decide. Okay, vector equation of plane passing through the points A bar. Now example, one example. The vector equation of plane passing through the points A bar is equal to 1, 0, 0 and B bar is equal to 2, 3, 4 and parallel to the vector C bar is equal to minus 1, minus 1, minus 1. The one way is, look here, one way is, if you want you can go by this one is, the first method is, the solution of this one is, now I can write OA bar is equal to A bar is equal to 1, 0, 0, OB bar is equal to B bar is equal to 2, 3, 4 and C bar is equal to minus 1, comma minus 1. Okay, you can very well observe, I can write box of vector equation is asking. If you want in terms of, I can write R bar dot of, okay, or else box of I can write box of AP bar S comma AB bar C bar is equal to 0. Now this is can be written as it is R bar minus A bar B bar minus A bar C bar is equal to 0. Write down this, that gives the what? Vector equation. That is in terms of A bar, B bar, C bar. So this can also be written in another ways. Determinant is equal to what? 0. Determinant of what vectors? R bar minus A bar, B bar minus A bar, C bar. Now R bar minus A bar. What is R bar? R bar is equal to X comma Y comma Z. R bar is equal to X comma Y comma Z. When it is X comma Y comma Z, yes, now X minus 1. Next Y minus 0, Z minus 0. Next 2 minus 1, 1, 3, 4, minus 1, minus 1, minus 1. You expand, this becomes X minus 1 into minus 3 plus 4, Y into minus 1 plus 4, Z into what is that? Minus 1 plus 3 is equal to 0. So therefore, I can write X minus 1. Next, that is minus 3Y. Next, plus 2Z is equal to 0. So therefore, I can write as X minus 3Y plus 2Z minus 1 is equal to 0 is the what? Equation of a plane. If you substitute in terms of this, you will get what? Vectors. This is Cartesian equation of a plane. If you want to find out the perpendicular distance, I want the perpendicular distance. P is equal to perpendicular distance from origin to the plane. What's a plane? Plane is 3x, x minus 3y plus 2z minus 1 is equal to 0, right? So therefore, now this is nothing but I can write mod d by square root of a square plus b square plus c square as I given already. Actually it is what? Modulus of ax1 plus by1 plus cz1 plus d by square root of a square plus b square plus c square. In place of x1, y1, z1 you are substituting 0, 0, 0. So therefore, mod d, this is nothing but minus 1 by square root of 1 plus 9 plus 4. Therefore, 1 by root 14 is nothing but the perpendicular distance from the origin to the plane passing through the 2 points a bar, b bar and parallel to the vector c bar. Followed? Thank you.